Hello, super people. Today we are going to review algebraic expressions. We're going to talk about what an expression is and what operations we can perform on an algebraic expression or a mathematical expression. We can call it a mathematical expression or an algebraic expression. So an expression is basically a mathematical phrase, and a phrase is like a short sentence in English. So a mathematical phrase, a mathematical expression, an algebraic expression all mean the same thing. An example of an algebraic expression or a mathematical expression or a mathematical phrase is something like this. 3x plus 2. This is a phrase. It's not a sentence. A sentence is something we call an equation, so we're going to talk about this later. 3x plus 2 is an algebraic expression. Every little part of this expression separated by a plus, minus, divided, or times sign is called a term. So 3x altogether is a term, and 2 by itself is a term. Now, these terms can also have different names. For example, when you have a number, just a number, like the number 2, we call this a constant. Constant because the number 2 is always going to be 2. It does not change. If you have a letter like x, in this case right here, we call this a variable. Variable because it changes. X means the number of something. For example, x is the number of apples we sell in our store today. We could sell 1 apple, so x equals 1. Or we could sell 5 apples. In that case, x equals 5. So x is a variable because it changes, whereas the 2 is a constant. Now, let's talk about the number 3 in the example we have right here. Is 3 here also called a constant? No, it's not. Because the 3 right here is not a term by itself. It's multiplied by a variable. It's times x. 3x means 3 times x, 3 x's. So since the number is multiplied by a variable, this number is called a coefficient. A coefficient. Okay? So we have a term, which is any little part separated from the other parts of the algebraic expression using plus, minus, times, or divided signs. Each one of these terms can either be a standalone number, like number 2 here, which is called a constant. It could be an x or a y, a, b, c, any letter. In this case, we call it a variable. And it could be a number multiplied by a variable, like number 3 here in this example, and in this case, we call it a coefficient. Let's take a quick example. Let's say we have something like this. 2x plus y minus 3. All of this is called an algebraic expression, a mathematical expression, okay? Now, each one of the parts separated by pluses, minuses, times, or divided signs is called a term. So 2x is a term, y is a term, and 3 is a term. But each one of these terms also has other names. The 3 right here is a number all by itself, so it's called a constant. The y right here is a letter by itself, or not by itself. Since it's a letter, it's called a variable. So the x right here is a letter also, so it's also called a variable. The number 2 right here is not a constant because it is not by itself. It is multiplied by a variable. In this case, it is called a coefficient. Okay? Super easy. Just wanted to make sure that you know the difference between a constant, a variable, a coefficient, and a term. Okay? Easy? Easy. Let's move on. Now let's talk about the operations we can perform on an algebraic expression or a mathematical phrase. This little sentence that we have, 3x plus 2, 2x plus y minus 3, 4a divided by x. All these are called algebraic expressions. What operations can we perform on them? What can we do to them? You can do the following. Number one, you can simplify your expression. Number two, you can expand your expression. And number three, you can factor your expression. Let's start with simplify. To simplify an expression basically means to try and make a long expression shorter, to shorten it, to simplify it. For example, if I have an expression like this, 3x plus x plus 2 plus 1. Can I simplify this expression? Yes, I can. How? The x's here are called like terms. 3x, remember it's a term, and x is also a term. Now we know that x is a variable, 3 is a coefficient. But what is the meaning of 3x? It means 3 times x. X and another x, 3 x's. Plus x, 1x. You can add those together. So I have 3 x's, 3 apples, plus 1x, 1 apple. Add them together, you have 4x. So we simplified. Instead of having 3x plus x, now we just have 4x. Now what about the 2? This is a term. It's a constant. What about 1? It's a term. It's also a constant. So they are like terms. They are similar terms because they're both constants. The number 2 plus the number 1 equals the number 3. So the 3x plus the 1x equals 4x. The 2 plus the 1 equals 3. And remember, we had a plus sign right here, so we keep that right there. Now, we simplified our expression. So instead of having 3x plus 2 plus 1, 4 terms, we just have 4x plus 3, 2 terms. Simplification. Easy? Perfect. Expanding and factoring are a little bit more difficult. Basically, if you want to expand an expression, this expression must first have parentheses or brackets. So, to expand an expression, it must first have something like this. It must have parentheses. It must have brackets. Then you can expand it because it has parentheses or brackets. Easy? Factoring, on the other hand, you factor something that does not have parentheses or brackets. Let me give you a quick example for each, and then we'll go into each one of these two in more details. So, go up to expanding, please. You want to expand this expression, 3 parentheses x plus y. When you have parentheses, you know that this means that the 3 out here is common to both the x and the y inside the parentheses. So 3 times x plus y basically means 3 x's and 3 y's. We do 3 times x, then the plus sign, then we do 3 times y. So 3x plus 3y. This is called expanding. So instead of it being inside parentheses, we open up the parentheses, we expand it. Factoring is the opposite of expanding. To factor 2x plus 2y, we first have to find something common between these two terms. 2x and 2y. What is common between them? The number 2, the coefficient 2. So we take 2 as a common factor, we put it outside, then we open and close parentheses like this. Here we have a plus sign, so we put in a plus sign. Now, the 2x plus 2y both had 2 as a common factor. I took the 2 and put it out here as a common factor. What am I left with? X plus y. Now, in order to return from this form to this form, what do? We expand, just like we did in step number 2. So expanding and factoring are both opposites of each other. One more time. Simplifying an expression basically means that you will try and add, subtract, multiply, or divide like terms. Here we have something x, here we have something x. We can add these two together to give us 4x. Here we have a constant and another constant by themselves, so we add them, they give us 3. This is called simplifying. Expanding is when you originally have parentheses, and we open it up, we expand it by multiplying whatever's out here by each of the terms inside the parentheses. Factoring is the opposite. You have an expression like 2x plus 2y, and I want you to factor it. I want you to transform it into a form that has parentheses. So I look at both terms, 2x and 2y. I ask myself, what is common between the two? The number 2 is the thing that is common between both. So we take 2 as a common factor outside, then we put in whatever is left inside. Okay? And to check your work, you expand this to get this. Very easy, very basic. Now let's get into some examples on expanding, factoring, and simplifying. We'll take easy examples and we'll take harder examples. Okay, ready? Okay, let's do this. So, first let me give you an example right here for simplifying. And here is an easy question, okay? Easy question. Let's say we have 2x plus 3x plus 1. And I want you to simplify this for me, please. I will first look at the terms that I have and ask myself, do we have like terms? And like terms means, do we have the same variables in different terms? And the other question, do we have constants? So yes, we have 2x, the variable is x. We have 3x, the variable is x. So these two can be simplified together. 2x plus 3x is 5x. Now let's look at 1. The number 1 is a constant. Are there any other constants here? Are there any other numbers by themselves? No. So we just rewrite the 1 as it is. Okay, let's make this a little bit more difficult. Let's say the question was 2x plus 3x plus 1 plus y plus 4y plus 3. Okay, let's do this time. So let's take this away and do this question now. 2x, 3x, any other x, any other x, any other x, any other x? No more x's. Add the x's, 2x plus 3x is 5x. Perfect. Now, we have a variable y. Is there another y? Yes, there's 4y. So we have a term y and another term 4y. Add these together, you get 5y. So plus 5y. Perfect. Now what do we search for? We search for constants. We have the number 1, constant. We have the number 3. 1 plus 3 is 4. So now we simplified our expression into 5x plus 5y plus 4. Easy? Easy. Now let's do one that is a little bit more difficult. I want you to simplify this one for me, please. Let's call it number 2. 4 over 3k minus 2 over 3k plus 1 over 3k. Now, it should be easy because each of the terms has the same variable, which is k. So you're basically going to add 4 over 3 and 1 over 3 and subtract 2 over 3. So it's like saying 4 over 3 minus 2 over 3 plus 1 over 3. Okay, 4 over 3 minus 2 over 3 is 2 over 3 plus 1 over 3. Okay, 2 over 3 plus 1 over 3 is 3 over 3. What is 3 over 3? It's 1. When you have the numerator and denominator equal to each other, the answer is 1. So we have 1k, that's the answer. And when we have 1 times any variable, the answer is just that variable. So the answer is K. Easy. Now let's take a few examples for expanding. So let's put a big 2 right here and write expand. I'm going to give you a few algebraic expressions, mathematical phrases, and I want you to expand them. And remember, to expand, you first have to have the expression in parentheses. So let me give you an easy example. 1/4. And then we have parentheses. So it means 1/4 times 4c plus 9. Okay? Now what do we do? We first take this right here and we multiply it, because when you have a number that is right next to the parentheses, it's as if we have a multiplication sign right here. Okay? So we're going to do 1/4 times 4c. So 1/4 times 4c. Then we put the same sign that we have up here, which is a plus. Then we multiply the 1/4 by the second part inside the parentheses. So it's 1/4 times 9. Easy? Perfect. Now, let's take a look here. When you have, of course, a denominator of 4 multiplied by a numerator of 4, they cancel out. So this is just c. 1/4 times 4 is 1. So 1 times c, c. Plus 1/4 times 9 is 9/4. Okay? So this is my answer. C plus 9/4. Of course, I could simplify 9/4 further and make it into a mixed number. Okay? I could change it into a number that has a decimal. I can do whatever. Let's just keep it like this now, c plus 9/4. This is called expanding. Let's take another example for expanding, please. Right here. Let's see. 0.3 times 5x minus 2.2. I want you to expand. Okay, here's what we do. We're going to take this number first, multiply it by this term right here. 0.3 times 5.x. So 0.3 times 5x. Okay? Then we take the sign as it is. We had a minus, so the minus stays as it is. We take this number, 0.3, and we multiply it by this number here, 2.2. Now let's solve. 0.3 times 5x. This is a number multiplied by a term that has a coefficient 5, a number, and a variable x. When you multiply a number by a term that has a number, coefficient, and a variable together, we just multiply the numbers by each other. So 0.3 times 5x is 0.15x. Okay, 0.3 times 5 is 0.15, and the x stays as it is. Then we do minus. 0.3 times 2.2 is 6.6. Correct? No, it's 6.6 if it's 3 times 2.2. Perfect. But remember, when we multiply decimals, we need to move the decimal in the answer. So if it was 3 times 2.2, 3 times 2.2, the answer would be 6.6. But since it's not 3, it is 0.3, that means we need to move a decimal point one place to the left. So the answer is 0.66. So here's my final answer. 0.15x minus 0.66. Easy? Easy. Excellent job. Now, let's take another example for expanding. Here it is. 6 times 3y plus 4 plus 5. Okay, now this is a little bit more difficult, and this is a y. Okay, let's make it like this so it looks like a y. This is a little bit more difficult because we have the plus 5 at the end. And here I'm going to ask you to expand and simplify. So I want you to expand and also to simplify to make this as simple as possible, as short and as small as possible. So let's first start with the parentheses, as usual. We do the 6 times the 3y. We do the 6 times the 3y. So it's 6 times 3y. Then we use the same sign. We have a plus. Then we put 6 times 4. Okay? Now this is equivalent to all of this. I just changed this. I expanded it into this. 6 times 3y plus 6 times 4. What about the plus 5? It has nothing to do with the expansion because it is outside the parentheses and there is a plus sign right here. If there was a multiplication or division sign, it would be a different story. But if it's plus or minus, then it has nothing to do with the parentheses. So we just put plus 5 at the end. Okay, now let's answer. 6 times 3y is 18y. 6 times 3, 18, and the y stays as it is. Plus 6 times 4 is 24. Plus 5 as it is. Now let's simplify. Let's start with the variable first. How many terms here have the variable y? Only one. There is nothing else except 18y. So it stays as it is. Now 24. What is 24? 24 is a term that is a constant. It's a number. Are there any other constant numbers without variables? Yes, there's 5. 24 plus 5 equals 29. So the final answer is 18y plus 29. Easy? Easy. Let's do one more. Let's move on now to number 3, factoring. And let's take a few examples. Let's start with easy examples and then make this a little bit harder. I want you to factor the following expression for me, please. 5x minus 25. Okay, now remember, to factor, we need to rewrite this into something that has parentheses. Now, in order to do that, I need to find something common between these two terms. The first term has a variable. The second term does not have a variable, it's a constant. If you have something like this, then the only thing that can be common between them has to be a number, a constant, okay? Because there's x in the first one, there's no x in the second one, so x can't be common, has to be something in both. We're actually going to do this the easy way and the hard way. The hard way is the way you learned a long time ago, and it is to find a common factor between two numbers. You want to find a common factor between the number 5 and the number 25. And we can use our factoring tree, we can do lots of things in order to find a common factor. Okay, that's the hard way. The easy way is basically to ask yourself, if I take the 5 as it is, just the 5, the coefficient, can I write this as x, put the minus as it is, minus something? Is it possible? Let's see. 5 times x is 5x, so that's fine. Minus is minus. I'm expanding now. I'm going in reverse. How about 25? 5 times what gives me 25? 5 times 5. Easy. So I just found my common factor, which is the number 5. Okay? Let's try a harder one. Negative x minus 3. And I want to factor this. Okay, the first term has a variable. The second term has a constant. Both terms don't have numbers like we did up here, and both terms don't have the same variable. They both don't have x, for example. So what can be common between these two? It has to be a number. But the first term, negative x, does not have a number. Or does it? It does, because negative x means negative 1x, just like x means 1x, okay? So there's actually a 1 right here. It's negative 1x. So I can take this as the common factor. But we never put 1 as a common factor. We never put 1 before the x in the first place. So my common factor right here will be the negative sign. So it's just a negative, then parentheses and x. Negative 1 times x is negative x. What about the 3 right here? If I put a negative like this, will this be the correct answer? No. Why? Because remember that any negative times a negative gives me a positive. So the way this is written would be negative x, if I want to expand it, negative times x is negative x, then negative times negative 3 is positive 3. This does not look like the original question. So this is wrong. Okay, then how do we do it? Here's how. You take the negative as a common factor, and you put the x. Negative times x, negative 1 times x equals negative x. We're good. Then put the 3. The negative times the 3 is going to give me a 3 right here. That's perfect. But we want it to be negative 3 minus 3 in the middle, not positive 3, not plus 3. So we need to put a plus sign in here, because we know that a negative times a positive gives me a negative. So this would be my answer. Negative x plus 3. Okay? A little bit tricky. Let's move on. Let's take another example, everybody. Let's see. I want you to factor the following for me, please. 15x plus 5x plus 10. Okay, again, you have two terms that have x's, that have variables, okay? But the third one does not. So the common factor must be a number, not a variable. For the common factor to be a variable, each one of the terms has to have that variable. And here the 10 does not have a variable. Easy? Easy. Now, I can do this two ways. The first way would be to just say, okay, I want a common number between 15, 5, and 10. And just to make things easy for you, always try the smallest number that you already have, which is 5. Is 5 a factor of 15? Yes. Is 5 a factor of 5? Yes itself. Is 5 a factor of 10? Yes. So 5 is my common factor. In order to make 5 times something equal 15x, we have to have an x. Okay, 5 times what equals 15? 5 times 3. So we have 3x right here. Then put the plus sign. In order for 5 times something to give me 5x, there has to be an x. 5 times what gives me 5x? 5 times 1 equals 5. So it's just x. Then put the plus sign. 5 times something has to equal 10. 5 times 2. So I'm done. 5, parentheses, 3x plus 2. Now, this doesn't look like the simplest form. Remember, we have to simplify. In order to simplify, we can add or subtract like terms. Here we have 3x plus x. These are both like terms because they both have the same variable x. What's 3x plus x? 4x. What about the 2? There's nothing we can do. We can't simplify it any further, so it's plus 2. So here's my final answer. Now, is there another way to do this? Yes. Here it is. 15x plus 5x plus 10. Now, in order for me to expand this, in order for me to factor this, I can simplify it first. So before factoring, let's simplify. 15x plus 5x both have the same variable, so we can simplify. We can add them together. That's 20x. And the 10 stays as it is. So now I have 20x plus 10. What's a common factor I can take here? I can take 10 as a common factor. 10 times what gives me 20x? 10 times 2x. 10 times 2 is 20, 10 times x. 10 times 2x is 20x. Plus 10 times what gives me 10? 10 times 1. So the answer is 10 times 2x plus 1. But wait a minute. This does not look the same as this. Why? Because you were wrong to answer this question before simplifying first. 4x plus 2 can be simplified again into 2 times 2x plus 1. And all of this times 5. I can just simplify 4x plus 2 into 2 times 2x plus 1. Now multiply the 5 times the 2, you get 10, and 2x plus 1 stay as they are. But this is a little bit more complicated, wastes time, and will probably help you get a mistake on the test. This is what you need to do. So remember, when you have an algebraic expression, and you are required to factor it or to expand it, try first. If you have an algebraic expression and you are asked to factor it, always try to simplify it first. Let me give you a last example on this point right here. Let's say you have a question like this. 3x plus 2y plus 4x plus 2x plus x. And I want you to factor this. Before you do anything, simplify. 3x, 4x, 2x, and x. Okay? 3x plus 4x is 7x. 7x plus 2x is 9x. 9x plus x is 10x. So 10x. What else are we left with? Plus 2y. Now you can factor. Okay? But never try to factor without simplifying first. Okay, let's solve this. 10x plus 2y. It's a little bit trickier because this one has a variable, x, and this one also has a variable, but it's y. They're not the same variable. Remember when we said if the terms don't have the same variable, then the common factor must be a number, right? It's the same thing here. If the terms don't have the same variable, even if they both have variables, the common factor will always be a number as well. So we're not going to look at the x, we're not going to look at the y. We're going to look at the numbers, 10 and 2. Always try to take the smaller number as the common factor. Let's try. Is 2 a factor of 10? Yes. Is 2 a factor of 2? Yes. What is the meaning of 2 is a factor of 10? It means 2 times something equals 10. 2 is a factor of 2. What does that mean? 2 times something equals 2. Okay? So, open your parentheses. 2 times what gives me 10x? 2 times 5x. Plus sign. 2 times what gives me 2y? 2 times 1y. So we just write y. We don't write the 1. So here's my answer. 2 times 5x plus y. Easy? Super easy.